sketch the graph of the polar equation r equals 4 times 1 minus sine of theta. Well, what I'll do first is point out that the form of this polar equation, r equals a times 1 plus or minus either sine of theta or possibly a cosine of theta here, is going to give us the form of a cardioid. And because of that, because we know this is a cardioid, we can save a little time as we try to produce a table of values to sketch this. Let me pause here and pop up a variety of values on the unit circle, and I'll talk about those in just a second. So here I've popped up some of those values. Notice if theta is 0, sine of theta is 0, 1 minus that is 1. And to get r, I need to have 4 times 1 minus sine of theta, so that's going to give me 4 times 1, or just 4. I did that for all the other columns as well. Let's, angles I should say as well. Let's plot those points. So a 0-degree angle points this way, and I have to go 4 units, so 1, 2, 3, 4 down that polar axis. At pi over 2, the radius is 0, so I'm pointing north, but I'm going nowhere, so I'll put a point here. In the pi direction, I'm going 4 units, so 1, 2, 3, 4 puts me here. And in the 3 pi over 2, or southerly direction, I'm going 8 units, so that's 2, 4, 6, 8, and I'm down to here. Now, as it stands, that's not enough to get a sense of the actual shape of this graph. So what I'm going to do with you is put in some other easy values for sine, in particular sine of pi over 6 is just 1/2. And if I do 1 minus 1/2, I get 1/2. And when I multiply that by 4, I get a value of 2 along the pi over 6 line. So 2 units puts me here. And if I were to go along this line, that's 5 pi over 6, I would similarly get 1/2, because the sine of 5 pi over 6 is the same as the sine of pi over 6. 1 minus sine is 1/2, and multiply by 4, and I get 2 again. So I have to go 2 units down here, and I'm right on that circle. Now, we're sketching the graph of what's called a cardioid, and that has the same Latin root as the word cardiac, which is to refer to a heart. And the shape that we're going to sketch actually is a heart-shaped figure. The bottom of a cardioid is somewhat rounded, so don't come down to a point the way you would normally do for a heart. But if you plotted on a few other points, you'd start to see, in particular, if you plotted points along like 7 pi over 6 or 4 pi over 3 lines, you'd find points in this vicinity. You can get a more accurate sketch if you wanted to individually plot those points. Well, knowing that the shape of a cardioid is going to have a pattern like this that may or may not be rotated on its side or upside down, this way, and it may be fatter or skinnier depending on the various shapes and the values of A that we have. But knowing that this is going to have a shape of a cardioid, it really allowed me to just plot these points, and those were the points I originally identified here, 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 and down here. From that, I would have had a decent chance at sketching the graph. If I wanted to get a little more precision, I could plot some of the other easy to find values. In particular, I used pi over 6 and 5 pi over 6 to get a better sense of how high the top atria of the heart extend. So that's the shape of a cardioid, and there's a decent starting point, at least, for a graph of that.